Hi everyone, I am Mihai, and for this video I'm trying out a different format. The vision I have for this type of videos is wrapping up interesting things I discovered or learned during a month. So it's sort of like a podcast combined with a newsletter in a video form. We'll see how this goes. Not sure about the timeline yet. I'm thinking the last Friday of each month, but it's not set in stone yet. Well, neither is the format for that matter. So we are going to have three sections in this long form video. First is the project spotlight, where I talk about projects or products I discovered and found interesting. The second section will have my own commentary on tutorial articles or videos that I found useful. And in the final section, I will be reacting to industry news where I might get a bit too philosophical, but we'll see how that goes. The topics I will cover will range from full stack development, databases, soft skills, business, basically anything that can have an impact on your tech career. So let's get started with the first project I discovered this month, and that is ParadeDB. If you're a fan of Postgres like I am, you're probably aware of the incredible ecosystem and innovative projects emerging around it. We've got TimescaleDB for time series data, PostgreSML for machine learning right inside your database, which I've actually made a video about in the past. This is why open source software is such a great thing. There's so much innovation going on in this space. ParadeDB is the latest project I discovered in this long line of products built on top of Postgres. So what does it do? Basically, it does two things: search and analytics. They call themselves an Elasticsearch alternative. So let's explore these two areas. I'm particularly interested in its text search capabilities. They give a few examples here: full text search, similarity or vector search, and a hybrid of both. So if you don't know, full text search is a type of search that is more advanced than, say, a keyword search or a like query. Specifically, it offers stemming. For example, words like walking, walked, and walks will all be valid results when searching for walk. It offers fuzzy matching and accounts for typos and variations of the same word. You can search for phrases. For example, you can search for software engineering as opposed to two separate terms, software and engineering. This improves the relevance of the search, and you can also rank the results based on this relevance and take into account factors like frequency and proximity of the words. Vector search goes one step forward. Instead of matching certain keywords, it tries to understand the meaning and context of words. It can find documents that are semantically related to the query, even if they don't use the exact same words. Real-world use cases for this would be recommendation engines, so you can determine similarity and recommend similar articles or similar products, for example. Now, for the analytics side, it uses DuckDB. DuckDB is an in-process analytics engine. You can check that project out to see the capabilities it offers. I have to say, Postgres is particularly well suited for this type of application since it has something called foreign data wrappers. So the idea is that you can reference remote data sets and work with them as if they were an object in your database. For example, this grabs a file from S3. So in the context of ParadeDB, foreign data wrappers are used to integrate with external data lakes, allowing you to perform analytics on data stored in those lakes without having to import the data into Postgres directly. I see there are a few formats for data that you can reference using foreign data wrappers. Old boring CSV, something called a delta table, an iceberg table, and Parquet files. And you can get data from Azure, Google Cloud Storage, or S3, or any S3 compatible system like Mihai, for example. I think ParadeDB is an awesome project and I can't wait to use it on one of my side projects, which definitely needs improved search capabilities. Recently I started learning Go, so subscribe to see my upcoming video on how I learned Go as a Node.js developer. And this next project combines Go with Postgres, so you can imagine why I was excited to check this one out. It's nothing innovative, it's a background or asynchronous job queue built on Go and Postgres. And it's an alternative to the various queues built on top of Redis, for example. You might have heard of Bool or BoolMQ, so this is very similar. However, it has a few advantages being built on Postgres. It uses transactions, so data consistency and reliability of the jobs is guaranteed. It has a bunch of features such as retries, prioritization, scheduling, isolated queues, and also a good looking web UI. Let's check out the demo. So it's pretty simplistic. We have a few queues, we can pause them, we can see all the jobs in different statuses. Yeah, so pretty simple. I'm excited about what they are working on, specifically this workflow feature they are teasing right here. So definitely worth keeping an eye on this one. Next up, PrimeVue. I'm mentioning it here because they just recently launched version 4. This is one of the best Vue.js UI libraries out there. I would actually name PrimeVue, VueStick, and Element Plus my top 3 UI libraries for Vue. Usually when I check out a UI library, it always comes down to these few things. Does it have a good date and time pickers? It does. Complex data tables? Check. Tailwind CSS integration or compatibility? Check. It even has an unstyled mode, which is basically a headless mode, and that's how you can use just the functionality of each component, but you can style it from scratch. Let's take a look at some of the awesome components PrimeVue has. So first, let's check out the date picker. Again, pretty sleek. Here's the time picker. You can also select the date range. Yeah, seems to have everything you would want. It also comes with a cool text editor. And let's see the most important thing, the data table. So let's scroll down to the more advanced use cases. Yeah, pagination, pretty standard. Sorting. Sorting, searching, filtering. Yeah, all of the good stuff. Let's see if they have expandable rows. And yeah, they do. This feature is exceptionally useful when creating data-heavy applications. So yeah, this library should have everything you need. You have the v4 migration guide right here. So yeah, definitely worth checking out. And finally, another UI library. There's not much to say here, but just look at this cool demo. So you can create this UI interface. This sort of like draggable grids that you can arrange and move and resize. And yeah, I didn't know about this one until recently, but I can think of so many ways of using this. So this one's pretty cool as well. Moving on to the tutorial section, the first one is about the old debate of UUID versus serial integers as primary keys. So here's the thing, UUIDs are so convenient to use, and especially in distributed systems. I use them all the time. However, their strength becomes their weakness in some situations, specifically the fact that they are random. To find things fast in Postgres, or most databases for that matter, we use a B-tree indexes. Now, B-tree indexes are ordered, so they make finding a specific value or range of values faster. However, how can you sort something that is random? Well, you can't. So keep in mind, whenever you insert something in a table, you also add a new entry to the index, and because we try to order something that is random, we cause issues like page splits. And Postgres then basically has to recalculate the index to find space for this new value. So inserts into the database get slower. Now you'll probably only notice this only on large-scale projects. I've used UUID v4 as primary keys on multiple occasions. However, now we have something better, and that is UUID v7, which offers all the same benefits as v4, The only difference is that V7 is time order, which makes a massive impact. Now, when you insert a new road, it will naturally be ordered, so this reduces page splits and the need for Postgres to rebalance the index. So this is pretty cool, and I started using UUID v7 as primary keys now. Whichever UUID you end up using though, it's important to use the UUID data type in Postgres to store these values, and not use the basic text data type. Some of the benefits for this are integrity and type checking, but also in terms of storage, UUIDs are always exactly 16 bytes long. Storing them as text would occupy more space because those have a minimum of 32 bytes. You can check out this article to learn more on this topic. Next, I came across this article and I really enjoyed it. I consider streams to be an extremely important concept to grasp in Node.js. This article seems pretty straightforward, tells you why you should use streams, the connection between streaming and event-driven architecture. It even covers an issue that can happen with streaming, which is called back pressure. Here's a nice diagram on how back pressure works. And this actually reminded me of a presentation I did a couple of years back. In fact, let me just show you a couple of slides. Hopefully I'm not getting into trouble for showing you this. So I was talking about scaling Node.js applications. And yeah, here I talk about the 3 dimensions of scaling. I start off with the batching and caching strategies, and then I go into streams, and this is the diagram I created. Let's try to zoom in a bit. So I made this diagram, and I think it's a bit more detailed than the one in the article. So what happens in a stream is data is sent in chunks, and these chunks can be piped or passed around to different transformers. The transformers process data in chunks as they come in. This keeps memory usage constant throughout the execution. Now here is how back pressure can build. If in the stream chain you have a slow transformer that is not able to process each chunk as fast as the sender can send them, then the excess data will build up in a buffer. And this is called back pressure. At some point the buffer can get full. You have to treat this scenario in your code to make sure that the transformer responds with false, if I remember correctly, and then the sender should pause the sending to allow the system to catch up. And that's the general gist of it. And yeah, go ahead and read this article to get a better sense of streams in Node.js. They are a pretty important topic in my opinion. Next, let's talk about the real lifesaver of a feature in PostgreSQL, which is select for update. Adding this clause to a query acts as a safeguard against concurrent access issues, essentially locking a row for exclusive use by a transaction. This is a fairly short article covering everything you need to know about the feature. So do you remember earlier in the video when I talked about River Queue? That's the Postgres-based job queue system written in Go. Well, this feature is especially useful for those types of applications. Without select for update, multiple workers might inadvertently attempt to process the same job, leading to duplicated efforts or even potential errors. By adding this clause, each worker can acquire a job with the assurance that it hasn't been claimed by another worker. I'm genuinely excited about the new set methods in JavaScript. In the past, tasks like finding common elements between arrays, identify unique values, or determining if one set is a subset of another often involved writing custom functions or relying on external libraries. Now with these built-in methods like union, intersection, and difference, we have an elegant way to perform these operations directly on sets. So yeah, go ahead and check them out. So let's move on to reacting to some of the news from the past months. And what better way to start this section than getting philosophical about AI, the land of endless hype. So this article from Sequoia debates whether AI is the next big thing or just another tech bubble. I mean, AI is marketed on everything right now. Your air conditioner now has AI, fridge, AI coffee makers. But let's get real now. No AI coffee maker can make a cappuccino like I can. Do you remember there were some CNET journalists who got replaced by an AI writing bot? Or the BuzzFeed layoffs where AI was touted as the future of content creation? Well, it's almost comical if it weren't so tragic. People are losing jobs because someone is making a bet on AI. So the internet is now filled with garbage content generated by AI and published by bots. I saw this tweet recently, and I'll put it up on the screen right here, that said I wanted AI to do my laundry and dishes so that I can do art and writing, not for AI to do my art and writing so I can do my laundry and dishes. And this is hilarious. It's a great observation about the misdirected focus of AI development. Why are we automating creativity when we could be automating the boring stuff? Have you also noticed how AI writes like every middle manager out there? Like seriously, it's crazy. It has all the buzzwords. Synergy, actionable insights, ideate, whatever the hell that means. And it's like ChatGPT did an internship in a corporation and has a master's degree in bullshit. Yeah, so here's an idea of what to automate. Would you even notice if the corporate emails you get at work were written by AI? Like honestly, I'm not sure I would. Actually, maybe there already are. So bottom line, the economics just don't add up. Hardware makers and cloud providers are making a lot of money while businesses struggling to implement AI are left with a hefty bill and questionable returns. In time, things might settle down and maybe there will be a balance where AI adds value, but right now it's a chaotic gold rush. Now on to something a bit more positive. Kubernetes and PostgreSQL, my favorite topics. And first up, holy smokes, Kubernetes just turned 10 years old and I'm here learning Kubernetes thinking I'm on the bleeding edge. Postgres and Kubernetes are, in my humble opinion, two of the most important technologies out there. Absolute powerhouses. I wanted to showcase this article since I already made a video about this exact topic recently, so check it out if you want to learn more. The name of the game here is using Kubernetes operators running on PostgreSQL in a declarative and GitOps friendly way. And I've just thrown three concepts at you without explaining them: Kubernetes operators, declarative, and GitOps. So let's break down these three concepts, shall we? First off, Kubernetes operators are pieces of software that are extending the capabilities of Kubernetes and also extend the Kubernetes API with custom resource types beyond what Kubernetes has out of the box. In the case of Postgres operators, they can handle things like provisioning, scaling, backups, and disaster recovery to some degree of automation. It's like having a dedicated DBA in Kubernetes. Again, check my latest video on this topic where I cover one of the best Kubernetes operator for Postgres out there. So what does declarative mean in this context? Well, it means describing your desired state. For example, I want 3 Postgres replicas. Instead of manually executing each step, Kubernetes then figures out how to make that happen. And GitOps takes the declarative approach a step further by storing your Kubernetes manifest in a Git repository, which enables version control, collaboration, and automated deployments. So you can easily roll back changes or track who did what. In my opinion, these are game changers. And I can't imagine running Postgres any other way. And there you have it. I hope you've enjoyed this experiment of a video. If you have suggestions on improving the content or the format or my performance for that matter, let me know in the comments. Don't forget to subscribe and I'll see you in the next one.